Hello students, I welcome you all to my channel Education Lane. So as I said in my last video that I am going to start classical mechanics. So here is classical mechanics, the first topic. So first I will teach you mechanics of a single particle. Okay, let me tell you first what is classical mechanics. I am sure you are aware about Newton's 3 laws. So objects which follow Newton's laws, they follow Newtonian mechanics. So classical mechanics is also known as Newtonian mechanics. Here today we will study a single particle. About single particle, its acceleration, its momentum, the force acting on it, what will be the value of the force acting on it or the formula for it. And after that we will study about conservation laws which are applied for a single particle. So let's get started. We consider a particle of mass here I am considering is neither too much more, neither too low. Too much more masses and too much less masses will be dealt by another theories known as general theory of relativity and quantum mechanics. Quantum mechanics will deal with the masses which are very low and general the masses which are high, which are much more masses. So classical mechanics do works in a range. So let us consider a particle of mass m. This is our Cartesian coordinate x, y and z. This is our origin O. Now this particle of mass m travels on some random path from point A to B. Let us draw two position vectors to position which point towards point 1 and point 2. This one is r1 and this is r2. Now what are these position vectors? I am considering that my particle while traveling on this path from A to B, now I am considering a small distance, a small displacement of this particle from here to here, from point 1 to from point 2. For this position vector means a vector drawn from origin to that point where the particle is, where the particle of mass m is. So this is my first position vector to point 1 is r1 and this is my r2. Now this small displacement will be del r, traveled in time del t. You know velocity is equal to displacement upon time. So the instantaneous velocity means velocity in small time which cover distance small del r. So instantaneous velocity will be del r upon del t. Got it? Now if we want it in derivative form, my del t would be 10 to 0 because now I am considering it my instantaneous velocity for some small time del t tends to 0. So this is equal to v or v for some at time t is equal to limit del t tends to 0 del r upon del t. I can write it like dr upon dt. So this is my velocity and this is my result for the velocity of a particle, of a single particle. Now this is my velocity. Let us do the acceleration. Now let us do the acceleration part. Acceleration is defined as the change in velocity per unit time or with respect to time. What was my velocity? From previous formula or the equation, this was my velocity, change in position vector with respect to time. I can write my acceleration like d2r by dt2. So this is my acceleration for a single particle. Now I'll tell you the force acting on the particle. According to Newton's second law of motion, my external force acting on the object is change in linear momentum with respect to time. Now what is linear momentum? Linear momentum is moment of force. Now what is moment of force? Means the effect of the force applied on the object. How hard it is applied on the object and in how much short time. How much time? If the time is less, the force will be increased in case of a linear momentum. Now the formula for linear momentum, P is equal to mv. I can write it like m dr by dt, right? From the formula which I derived. Now the external force is equal to dp by dt. Now let us put the values. M dr by dt, d by dt. Now because mass is constant, so I have taken it out and I can write it like this is my force in terms of position vector. This you also know is acceleration. Hence the formula which you used to read about force is equal to ma or F is equal to ma is proved. Now this force is in terms of position vector. Now I will do the conservation laws. What are conservation laws? Before telling you the conservation laws, I would like to tell you the difference between conservative force and non-conservative. Let us see the difference between conservative and non-conservative force. Conservative forces are those forces which depend upon initial and final points and not on the path followed. Say for example, particle, I have particle here, I have particle here. Now the force between these particles or will depend upon, my force between these 2 points will depend upon the points, how far these points are, not on the path followed. Result will always be same. Example, gravitational force. Gravitational force will depend upon point 1 and 2. How far these point 1 and 2 are. It will not depend upon the path taken. Will always take a straight path from point 1 to point 2. Another example is electrostatic force. In case of electrostatic force, these points will become the points of charges. 2 charges will be put here and the distance between these are measured, and thus we can calculate the electrostatic force. So I can write it like forces which depend on initial and final points and not on the path followed. Whereas non-conservative forces are the forces which depend on the path followed and not on initial and final points. Got it? Example, frictional force. Frictional force is always act opposite to the direction of motion, and it depends on how much distance is traveled, how much path is traveled. For example, from point 1 to 2, if I travel straight, my frictional force will depend upon path, because frictional force always act on the surface of contact. So as it will act on the surface of contact, so for this, let us say frictional force is F1 acting all along from path 1 to 2. Now for this F2, now you can see this path is bigger than this path. Frictional force acting on this path is F2 because it depends upon the point of contact. So the path taken is longer, so the frictional force will be greater. So this frictional force is depending upon the path taken and not on the initial and final points. Another example is air drag. What is air drag? Suppose there is in some direction from A to B and you are going from B to A. Now there will be some force which will act on you, that will be air drag. If the path is shortest, air drag will be less. But if you take longer path, if you take this longer path, air drag will be more for you. So air drag and frictional force, you can think of another examples as well. So these are examples of non-conservative forces. So now let's get started with the conservation laws. There are basically 3 conservation laws which I am going to tell you. Conservation of linear momentum, conservation of energy, and conservation of angular momentum. So conservation of linear momentum. Linear momentum I have already told you in this video. What is linear momentum? Also the formula for it will be mv. According to Newton's second law, it is related to force in this form. Now what the conservation of linear momentum says? It says the linear momentum will remain conserved, that is, it will remain unchanged. Its value will remain same before and after an event. After any event which is particle going through. Only if the external force applied on the mass is 0. So if I consider the external force applied on the system is 0, then I can write dp. dt is equal to 0. Now according to the formula, this term will be 0 only when momentum or when this term is constant. Good. So my linear momentum will remain conserved as long as the force acting on it will be 0. So this is your first law. This is first conservation law. This is very easy. Now proceed to the conservation of. Now let's proceed to the conservation of angular momentum. I will tell you the formula for angular momentum first. L is equal to R cross P. I have already told you that angular momentum will be momentum of a particle which is traveling in some circular path. This is the position vector of that particle from origin or from the center of that path to the point where the particle is. For example, this is O, the particle is here, this is R. This is the position vector of the particle here, particle of mass m is K. Right? Now here here also we will consider that the external force applied on the system is 0, then the angular momentum will remain conserved. But let me please tell you again that in a circular path, if momentum changes to angular momentum, the force will also get a new term, torque. Torque represented by tau is equal to R cross F. It is the force which is acting on the particle while it is traveling in circular path. R is the same position vector. Now let us relate both relation between them. Differentiate first term with respect to time, d by dt R cross P. According to the formula, differentiate this first, let it be remain at its position, and then plus differentiate this and let it be remain in its position. See how? dr by dt cross same position plus r cross same position. In vectors, the position of any vector matters. How? There are formula, the condition will change. A cross B is not equal to B cross A in vectors. A cross B is equal to minus of B cross A. In my next video, I will tell you about the vectors and scalars and some formula of vectors also. So let's back to our point. What is this? This is in velocity. How can we write momentum like this? R cross. What is my this? F. Now V cross V will be 0 by. Suppose V is in this direction. Again the velocity vector this. So they both are parallel. So for parallel vectors, the cross product will always be 0. 0 plus torque. Now L dl by dt is equal to torque. If the external torque applied on the system is 0, then dl by dt will be 0, or this will be 0 when this will be constant, and hence my angular momentum remains constant if the external torque applied on the system will be 0. So now let's move on to the last conservation law, conservation of. Now let us do the conservation of energy. There are two types of energy, kinetic energy and potential energy. So here we are talking about the complete energy, the sum of kinetic energy and potential energies. So first let us do the kinetic energy and then proceed to the potential energy. We'll see the relation and we'll prove that total energy before an event and total energy after an event will be same. So let's get started. Work done in carrying a particle from point 1 to 2. Which are these points? I have already told you about this graph. A to B, 1, 2. This is O, this is X, Y and Z is the position vector. So from point 1 to from point 2 will be the force acting on the particle to distance dr. That was my small distance dr. Now I will integrate it. I will sum up all these forces acting on the particle for such small distances from point 1 to 2, and I'll get the work done in carrying an object from point A to B, from point 1 to 2, not A to B, from point 1 to 2. What is force? Force is m dv by dt. I can write it. What is dv by dt? Is acceleration. F is equal to ma. So I write it directly like this. 1 to 2 m dv by dt. Multiply and divide by dt both sides to integrate with respect to time. Take m out. 1 to 2 dv. Now if you differentiate v square by 2, v is vector quantity. With respect to time, you will get the same quantity. You wanna see how? Let me tell you. D by dt, v square by 2, v is vector. Take 2 common, d by dt of v square. So this will be half. I will differentiate this. This will become 2 because v is vector. So dv by dt. 2 से 2 cancel. And this is same. Or if dt is dt cancel, you can write v square. This 2 is here. Differentiating and integrating at the same time will get you the same result. From point 1 to I have represented my kinetic energy with the term T. T2 kinetic energy at point 2, kinetic energy at point 1. So remember this result. T2 minus T1 is 1. Now let's move on to the potential. Now, any conservative force can be expressed as a function of some scalar potential. Now the conservative force can be expressed as a function of some scalar potential. The force can be expressed as negative of gradient of some function v. This is potential. Potential is basically the energy. Potential is basically the energy required to carry a mass from one point to another. From one point to another. This is gradient. Means increase. Means with the increase of the distance, increase in some quantity. Now what is this negative shows? This negative shows that with increasing distance, this value is decreasing. Del, I can write it like d by dr. This is my potential. I can write it like good. Now work done in carrying a particle from point 1 to 2 will be F dot dr. This will be 1 to 2 negative of d v of r. Here v is the potential. Now integrating and differentiating at the same time will give me the same value. This will be 1 to 2. I will simply write it as v, not this is understood. v2 minus v1, v1 minus v2. What was my first equation? T2 minus T1 is. Now this work done is same. So equate both these. So kinetic energy at point 1, sorry, total energy at point 1 is equal to the total energy at point 2, and hence my energy is conserved. Correct? So that's all about the today's topic of mechanics of a single particle, in which I have explained you some terms of acceleration, force and some conservation laws. In the further lectures, I will tell you about mechanics of a multi-particle system, mechanics of a system of particles basically, its conservation laws, center of mass, equation of motion and so on. I will also upload a video on vectors. Vector is very important for physics. So in the upcoming video, wait for vectors video. So this is all about today's lecture. Thank you so much, and don't forget to subscribe my channel for further videos, which is Education Lane. Thank you so much.